So, in this video, I want to talk about how AI creates videos from a prompt. As you know, video gen models are just becoming better and better. And I think it's important to understand what are the mechanics behind the video generation when you type a prompt in natural language. So this video follows naturally from a video that I did earlier, which is how does AI generate images from a prompt? I think the basics are good to know because video generation is an extension of image generation. So the link to this video will be in the comments. So let's understand the base first, which is images is basically a single frame, and video is nothing but images over time. So same foundations as Imagen, but now add motion, time, and consistency. So image generation is basically predicting the next pixel. Video generation is predicting pixels over time. And even though the base foundation may be the same, but video generation is obviously much harder because you're not generating just one image, but you're now having 24 to 30 frames per second while maintaining character consistency, background, lighting, motion, and style. So it is definitely much harder. So, if you had to just compare image generation versus video generation, as you can see, image gen is basically a single frame, one prediction, no time factor involved, and static consistency. Whereas with video, all of the same, but not just one, but sequence of frames, continuous prediction, time and motion, and temporal consistency, which is basically continuity over time. So if you've taken, say, for example, a lady in a blue dress, she needs to be consistent in the frames. So that adds a bit of complication when it comes to video gen models. So now let's understand what are the various elements which happen when we type that prompt in natural language and get that video output that we are looking for. And it is best explained by taking an example. So here's a prompt: a woman walking through a street market at sunset cinematic style. I just took this prompt and I put it in Canva AI to generate a 5-second video. So the text is obviously broken into tokens, and example is woman walking street market sunset cinematic, and these are the basic units the model will work with. The tokens are converted into numerical vectors, which are called embeddings. Embeddings will capture the meaning, not the grammar, right? And related concepts will sit close together: sunset, warm light, walking, motion, cinematic is camera, and lighting style. This is the same concept that I covered in the video for image generation as well, where similar concepts sit together, and that's what helps the model. From the embeddings, the model will form a high level plan for the video. So it'll have like a scene understanding, say, a street market, stalls, people, showing, say, fruits or vegetables. If you've been specific about the market, for example, sunset means warm tones, long shadows, then it'll have a motion understanding. So I've said woman walking down a market, right? So walking, so forward movement, the camera may follow or pan. And then there could be some style constraints, for example, cinematic, changing of the lights, or whatever kind of the prompt that you have written. And as the concept of diffusion happens in image gen models, it happens in video gen models as well. So the video will start as a pure random noise. It will generate multiple frames together, and then it will remove noise step by step using video diffusion. And then it will ensure consistency within frames and across time. And as it goes frame by frame, it will keep checking whether this matches the prompt and does it flow smoothly. So this is where you'll have the motion appearing, walking, the lighting stays consistent, objects remain stable. So if it's the same person, same scene, it ensures that it's not changed. And this is one of the reasons why the AI generated videos work really well if you have a single character and not multiple characters. And then the final steps, which is the temporal consistency and refinement. The movement should be smooth, it should be seamless, the market should not reset for every frame, The lighting and the style sort of stays consistent. So very sharper details are looked at, and some sort of, natural motion. So many a times you would have noticed that even if your prompt is not very detailed and it's literally, say, a single line, example, a cat sitting on a wall, but because of the training of these video models, wherein they've been trained on what comes before and what comes after, the AI is able to generate, say, a 5 second or a 6 second video for you, right? And like I said, it's because of the training on massive data sets of video clips and the frame by frame sequences. And it's also paired with captions like, say, a person walking, camera pans left, a car drives past. Now, if, for example, it's been trained on the fact that the cat jumps, away from the wall, then you're likely to see the same in the video that you generate. If, however, it's just cat sitting on the wall for 5 seconds, then so be it. So that's where the training aspect obviously comes in, and what kind of data it has been trained on. And this is what I was coming to, which is that video models will predict the next frame, and each frame prediction is based on previous frames, the prompt embedding, and the learned motion patterns. So if text leads to the next word, image is the next pixel, and for video, the model needs to predict the next frame. So the video models will predict smooth transitions, coherent motions, and no sudden jumps unless, of course, the prompt asks for it. So in this video that was of the woman walking down the market, it's just a very smooth flowing video, and there's no sudden jumps or changes. Now, I've been playing with video gen models quite a bit, right? And this is a question that seemed to bother me, which is, why is it 5 seconds or 10 seconds or 15 seconds? I also met some people, at some of the events who would say, like, I'm able to create only an 8 second video, but, I'm looking for something longer, right? With a single prompt. And that is really hard and challenging. So let's look at why do video gen models have, time limits. Now, as we talked about earlier, right, video is many images plus time. It is not a one time generation thing, right? There are 24 to 30 frames or images per second. Each image must look good, match the prompt, match previous frames. And so, for example, a 10-second video at, say, 24 frames per second is actually 240 images. A 15-second video is 360 images, and that is a lot. And as we saw, temporal consistency is not easy. The model must maintain character consistency, object consistency, lighting consistency, and motion smoothness. And the longer the clip, the more chances for drift, the more chances for error. And that is when you start seeing things like, hands changing shape, faces morphing as soon as the camera angle is zooming out, and some objects, disappearing in the long clips. And so the compute cost will also explode. Video generation is extremely expensive, right? And that is the reason why the providers need to cap the length to control the cost, to keep the latency reasonable, and also to avoid crashes. And the longer the videos, the errors will also start accumulating over time, which is why, say, this 5 second clip looks absolutely fine and beautiful. But as soon as you increase the time and start adding a little bit more complexity, things are going to start falling apart. And the last reason is obviously it is easier to train the model on shorter clips. So they've been trained on massive amounts of short clips, right? Loosely edited, not long cinematic sequences. Sometimes there's no head or tail to those videos, right? And that's the reason why you're absolutely okay if it's a short duration video. I think that 2026 is going to be a great year for we will see massive improvements in video gen models. They've already become so much better than what we saw even just a year back, right? And currently, if you just explore, there are a lot of good models out there. There's Kling, there's Van 2.6, Google VO3, Sora 2. And again, the question to ask is not which is the best model out there. The question to ask is, here's the task that I'm looking to accomplish using the model. So which model is best suited for the task that I have at hand? And here's just a one liner about each of these models. Again, the question to ask is, find the right one for the job versus sitting and comparing which is best. So, to summarize, basically, video generation is image generation plus time, plus motion, plus consistency, plus also remembering what was in the previous frame. And video models will keep getting better because there'll be better training, there'll be more compute power, and there'll be better models out there. If you think you have learned something from this video, do consider subscribing to my channel. And until then, stay tuned for the next one.